Welcome back, guys. Today we are going to show you guys how you can set up your own solar system based on very simple components, so let's get going. First of all, we start with the battery. In this example we will be using a lead acid battery. You can basically use any type of battery out there, anything from lead acid to lithium to nickel cadmium or nickel metal hybrid. So there is actually plenty of sources out there, but the most common ones today is lead acid or even lithium ion batteries that you see in the DIY Powerwall systems. A lithium battery generally have a lot more higher density, so that means more punch or more energy per kilo. But lead acid will work just fine. One thing that is really easy with the lead acid is that you don't really need to care much about balancing. It's just generally about float and bulk charge. Secondly, we need something to hook up the battery to the charge controller itself, and that is this one here. As you can see in the end here, we have two things, and one of them are marked clearly with the red tape, and that's the positive end. The breaker itself that I'm using is a 2-pole breaker. This one is rated for DC current, of course, and I have linked in them down below if you want to buy something like this. Just make sure that the voltage and the current is rated correctly before you buy them, and I do recommend a higher quality one than the cheap Chinese ones. In my case here I'm actually using a 63 amp breaker, and that is more than enough for the current application. And in this purpose here, as you can see, I'm using XT60 contacts to hook this up to the charge controller. The charge controller that I have here is a rather cheap one, but still not the cheapest one you can get. This is an MPPT controller, and that's one that I recommend. Do not go for the PWM. This one can do everything from 12 volt up to 48 volt. And it's always good to mention that the voltage and the battery type for the solar system need to match up. Generally, the solar input voltage need to be a little bit higher than the voltage on the batteries. This though depends on the type of the charge controller, if it's a buck or boost controller. This one takes everything from 15 volt to over 100 volt in input from the solar panel. So basically a 12 volt system, you need somewhere between 15 to 20 volt in input at least. A 48 volt system needs at least 60 volt in the input. As you can see here, got several different input. You have the solar input, you have the battery and the load output. And as you saw in the beginning, I have hooked up the XT60 contact to it as well. This specific unit also can be configured from the computer via the RS232, the serial port, and you can also configure it via this control panel on the front page. It also has the temperature sensor, and that can be really good to maintain the battery temperature and the voltage level correctly. So it's really nice to have if you have different temperature during the year. Next part is the cable goes from the charge controller from the panel. XT60 contacts here as well, as you can see, and I'm using only a single pole breaker here, and you should be using a 2-pole everywhere if you can, because the solar panels are generally not hooked up to the ground. I'm using a DC rated breaker here as well, correctly rated of course. I think this was a 10 amp breaker. Always pick the one that's properly designed. I also recommend that you have proper lightning protection. The lightning protection itself will protect your gear a lot. I have MC4 contacts that hook up from this breaker to the panel. And on the panel, as you can see as well, this is a 60 cell panel, and it produces somewhere around 40 volt open circuit, and closed loop it is around 32-33 volt. And as you can see here, they have the same type of contacts, the MC4 contacts that are the most common ones. I also bring out the voltmeter, and this is so we can cross-check the voltage and also cross-check the polarity of everything before hooking it up. So let's hook this together now. First of all, you always start with the battery. So let's do that. Turn the breaker off, that's the first thing you do, and then you hook it up to the battery. My battery in question actually have M8 screws. When that's done, we go to the next part and we are going to hook it up to the charge controller. Off still, and we check the polarity and everything. As you can see here, I cross-check the cables going from the battery, the red one, following it all the way through the breaker to the contact, to the next contact, and into the inverter or the charge controller. And then I hook it up. It's now time to flip the switch on. Most of the controllers will go bad if you do this wrong. I have done it on this controller itself, and I did burn the main board on the first version because I hooked up the solar first. Turning it on, and the controller lights up. It's not really easy to see on this image here, but it actually turned on. So the next part now, before we hook up the solar, we actually need to set up the charge controller. Unfortunately, I don't have any footage of this, but basically just set the float and bulk voltage levels. It's rather simple. Use the followed program and do it that way. If you wish, I could do another video later on with how to do that. But now let's fast forward to the rest of the parts. So when that's done, we go for the next step, and that is to hook up the solar panel. And if you want, you can always check the voltages and check the polarity before that. So let's do that a little bit quick. I have set it to voltage DC, the 200 volt. And we can see that the open circuit voltage around 37 volt. Once again, turn the breaker off, and we hook up the MC4 contacts to the solar panel, and they should click firmly, then you know that they are connected. And before we hook this up, we are going to check the polarity. So I take my voltmeter again, and the positive should be on that side, and that on that side as well. So let's see if we take the positive from the voltmeter and go to the negative and see what it says. And dang, it shows negative instead. So that means we have wired this wrongly. So we need to change the polarity on the cables again. And that is why it's so important to do this, because otherwise I would have danged the inverter or the charger. We have changed it now, so let's cross-check the polarity again and see if we have it correctly this time. And now we can see that the positive actually is positive, and we are good to go to hook it up to the charge controller. So make sure that the breaker is off still, and we hook the contact in together, and this is just to make sure that we don't get any sparks. And we flip the switch and turn it on. And by flipping the switch, we can directly see the blinking on the charge controller, and that means it has started to charge. So let's measure the battery now. I know that the battery was just below 12 volt before starting. So let's see the voltage. When we have 12.3 volt, that means the charge control actually started to charge somewhat. Unfortunately, I don't have the clamp meter handy here, so I cannot show you the current. So basically, this is the simple setup. We have the battery here, the crimped cables mounted properly, going into the breaker, the 2-pole breaker, and with a proper current, and it's made for DC as well. This is very, very important. Connected to the charge controller. The charge controller is of course connected via another breaker. Should be a 2-pole connector, and of course rated for the correct voltage and amperage going from the solar panel. Wires used here, I have 4 square millimeter solar system cable. The battery is a little bit too thin, it's 6 square millimeter, but it's fine for this single panel in this case. Always design the cables to be a lot bigger than the fuses. And as you can see, I have the computer hooked up here, actually setting the parameters and everything, and I cross-checked with a multimeter that everything was correct from the beginning. And as I said before, always engage the battery before you're engaging the solar panel, otherwise you will get problems. So basically guys, this was this for this time. It was a quick round where I show you guys how you easily can build your own solar system in terms of the panel, the charger and the battery part. So basically you can do it a lot more heftier and even a little bit simpler, but still I think this is the basic components needed for the start. The charge controller, of course. Down below I have linked in everything used here, so if you want anything, check those links out. You can buy most of the things on eBay. So once again guys, don't forget to subscribe, press the link, thumbs up, and see you next time.